Hey there, Earth Science fans. Did you know that there's a planet called K218b that's 124 light years away from Earth? And it orbits its star in a way that makes scientists think that there could be alien life on this planet. What makes them think that? Well, they estimate that the temperature is about right to support life, and we've also witnessed that there's probably water in the atmosphere, water being almost essential for life as we know it on Earth. So, how do scientists know all that stuff about a planet so far away from our own? So much of what we know about these planets far away from our solar system comes from studying the stars around which they orbit. As the planet orbits the star, if the star's light passes through the atmosphere, like in this position, the light from that star in the background would pass through this planet's atmosphere, the light that we get from Earth from that star changes a little bit, and we can tell what might be in the atmosphere. We can also study the star to tell how closely that planet orbits to the star, which would give us a good indication of what temperature might be there. So the atmospheric conditions and the temperature on the planet would be pretty good indicators that there might be alien life on these planets. So what this example reveals is that we can learn so much about space by studying the types of energy waves that travel through space. And as they travel through space and we can pick them up on Earth, we can learn about things that are way far away from our planet, like distant stars, distant black holes, even other planets where there might be alien life. Make sure you're keeping up with your thinking rights as always, and let's go over some of this vocabulary to set us up for the lesson today. The electromagnetic spectrum is the name of the range of all possible types of energy. So this refers to radio waves, microwaves, infrared waves, visible light waves, ultraviolet rays, X-rays, and gamma rays. Basically, these are all invisible types of energy that travel through space. Radiation refers to how these waves travel through space. Basically, they shoot out from their objects, travel in waves through space, and if we can pick them up with telescopes, we can learn more about them. Wavelength is a measurement of the distance between two waves. Basically, you could have a decreasing or short wavelength or an increasing wavelength, which means that that wave is going to be a little bit longer. So quick callback to a previous unit, we actually learned about waves already once before. We talked about shortwave visible light that the sun radiates, and then when the Earth absorbs it, it re-emanates as long wave radiation, which greenhouse gases absorb, which is causing our planet to heat up. It's causing global warming. So the greenhouse effect was already a preview about these electromagnetic or invisible waves that we're learning about today. So in general, we can divide our waves into two categories, short waves and long waves. Now the short waves are the high energy waves. Those are the ones that are going to be more dangerous because they're short waves. They're more concentrated energy per wave. These are the ones that could damage human cells, possibly causing cancer if you're talking about radioactive energy. Gamma rays and X-rays are examples of short waves that can be harmful. Gamma rays can shoot out from supernovas or dying stars as they explode. They shoot out gamma rays through space. And also, like I said, radioactive sites can give off gamma radiation. And these are the ones that have a lot of energy. They're harmful shortwave radiation. And like I said, the longer waves have lower energy, so they're relatively safe. Anything involving communication like radio waves or microwaves are relatively safe because the longer waves don't have as much energy. That means they're not going to be harmful. So cell phones communicating with each other or satellite dishes communicating around the world, those are radio waves. And that's why I'm not so worried that my cell phone's going to cause cancer, because those long wave radio waves are not that harmful because they don't have that much energy. All right, so let's take it back to the electromagnetic spectrum, which is really a graph that's organized with all the waves, the short waves on the left here and the long waves on the right. Now remember, these shorter waves are going to have more energy, so gamma rays has the highest energy content of any type of wave, and we can compare them. And even though there's some overlap, we can say that gamma rays have a shorter wavelength than X-rays because gamma rays are further to the left of that chart. That would mean that gamma rays have, in general, more energy than X-rays. On the right, the longest waves are radio waves, and we can compare those as well. Compared to microwaves, radio waves have a longer wavelength or less energy content. Now, maybe the trickiest part of the electromagnetic spectrum is the type of light that we see. That's visible light. That's the light from the sun that illuminates the planet. And it's all the colors of the rainbow composed in that light. Violet or kind of purple, blue, green, yellow, orange, and red. And those are also organized on the left side having the shortest waves and on the right side having the longest waves. Now, the reason that I think the visible light part of the graph is so confusing is that these dotted lines here show we have to imagine visible light being in between ultraviolet and infrared. It's such a small part of the electromagnetic spectrum that they kind of wanted to zoom in on it, and that's what the dotted lines show. So we have to imagine all of that information being in between ultraviolet and infrared. So, for example, violet light would be right here, and that's going to have a slightly longer wavelength than ultraviolet light. And red light would have a slightly shorter wavelength than infrared because we have to imagine it being in the center there. All right, so obviously there's a lot of new vocabulary today, but mostly if we can read and understand this graph, we'll be okay. These are all the invisible and visible types of energy that travel through space and around our planet that tell us a lot about the universe and help us communicate with each other. All right, that's it for me. I'll see y'all next time.